The internal structure of the Earth is layered in spherical shells, a solid inner core, a liquid outer core, a highly viscous mantle, and an outer silicate solid crust, which is split into tectonic plates. The strongest earthquake happens on transfer plate boundaries, where two tectonic plates are moving past each other. Friction builds up until all the energy is released in the form of an earthquake. The focus is the point in the crust where the energy is released from, and the epicenter is the point on the surface directly above the focus. On September 19th, a magnitude 7.1 earthquake struck Puebla, Mexico. Mexico experiences some of the strongest earthquakes in the world as it is an intersection of three plates. There were 370 fatalities and a further 6,011 were injured. However, it's not the earthquake that kills people, it is the failure of our structure that does. As engineers, our top priority is to construct buildings that are able to withstand strong seismic activities and prevent collapse. The shaking of the earthquake causes our buildings to oscillate, which can cause severe damage. We must avoid using brittle material as it causes sudden failure. Instead, we should use ductile materials as they are able to absorb energy of the earthquake. Engineers should ensure buildings have strong connections that can withstand the vibration of the building, as well as using brace frame structures to absorb lateral forces through the members. We constructed the building using wooden sticks, tape, straws, and blue tack that could resist applied forces in a shaking machine. We used engineering methods such as bracing and strengthening connections. Through this, we were able to assess how our building responded to strong vibrations, and thus, we learned what we needed to modify in the future. Another effect of earthquakes are landslides. Landslide can lead to loss of life, further damage to buildings, destruction of power supplies, and roads. Landslides occur when the shear forces from its own weight and forces from the earthquake acting down the slope is greater than the frictional forces holding up the soil. A slope is stable when the slope angle is less than the friction angle. Friction angle is the maximum angle granular soils can produce under gravity loading. Engineers can carry out scale tests on granular soil samples to analyze its behavior so they can prepare and adapt the surroundings for an earthquake. During an earthquake, we have to evacuate large quantities of people to a safe zone quickly and efficiently. Engineers should take into account an evacuation plan which includes clear routes, crowd management strategies, along with clear signage. We must avoid bottlenecks as it leads to arching, jamming, and causes a wake effect, which is inefficient. Furthermore, we should avoid U-turns and mixing vehicles and pedestrians. To conclude, our objective is to aid those who already suffered from Mexico earthquake. In addition, we seek to provide detailed developments and discoveries in methods to minimize the negative impacts caused by earthquakes for the benefit of mankind.